Okay, guys, so I'm sorry I'm out today, but Miss Delk and I wanted you all to be able to do the notes so we wouldn't get a day behind. So today we're going to be focusing on something called roots. Roots, we've kind of been talking this just a little bit. It's the point or points at which the parabola intersects the x-axis. I remember we've been talking about how the shift kind of goes from a y-axis to an x-axis. So this is how we learn to where the parabola will touch the x-axis and at which points. Let me say that better. If the parabola touches the x-axis, at which points it will touch. Okay, roots, there are multiple names, are otherwise called x-intercepts. So think about what that means. Every time we have an x-intercept, we let y be 0. Okay, another word are called solutions, because if we find the solutions to that equation, they would be the x-intercepts. Another word we have is zeros.
Because y is 0.
Because y is 0. Perfect. That's what we like. We like x. So anytime the parabola touches, crosses, or does not cross the x-axis is when we would have roots. Okay. All right, Ms. Delk's going to kind of sketch what this is going to look like. So when we would have two solutions, we would have a parabola that intersects the x-axis twice. Okay, so look at what she's doing. She's going to kind of circle where it intersects. And we're just sketching, so we really don't know those numbers at this point. But notice that we would have two answers for that problem. It would have two answers because it intersects it twice. Therefore, we would have to go to set notation. Remember, we would have braces, least to greatest, and we wouldn't repeat a number. So watch her write how the answer will look once we get it. So see that? She's got two solutions. So if we have two answers in math, we go to set notation, least to greatest, can't repeat. And it's always x equals. X is whatever two numbers make this happen where the parabola crosses. Okay. A one solution parabola. Think about what it would mean for a parabola to have one solution. It actually means that the parabola's vertex would be on the x-axis. See that? The turning point would be touching the x-axis. So therefore, it only touches one time at the vertex. So it has one solution. So remember, that's otherwise known as x-intercepts, otherwise known as solutions, otherwise known as zeros. And that's when we are just allowed to put x equals a number, because it only touches once. All right, so see the difference. Two solutions, one solution. So think about what a no solution would look like. Look like something like this. Okay, look at that. Never touches the x-axis, nor will it ever. It's got a vertex here, and it's going up forever.
It can touch the y-axis, but we're asking for its solutions, its roots, its x-intercepts, its zeros.
So it will not have any. So that's when something has no solution. So look at that. Like, that's pretty easy to understand. Two solutions, two answers, least to greatest, set notation, can't repeat. One answer, x is da-da-da-da-da. No answers, so that would have no solution. Okay, there are multiple ways to find roots. Let's get that straight. We're going to start with the easiest way, which Ms. Delkin I think is graphing. So today we're going to be graphing to find roots. But there are other ways. There's factoring, there's a process called completing the square, and there's quadratic formula, all of which will do the same thing. They'll all give us roots. Today we're going to focus on the graphing part, which is good, because technically y'all already know how to graph. That was on your last test. Can you graph a parabola? So Ms. Delk is doing number 1. Notice it's in standard form. So that means if it's in standard form, we're going to go get us an axis of symmetry by using our little x equals negative b over 2a. Okay, plugging in those numbers. She did axis of symmetry and got x equals 0. So 0 became our x value. Remember, we take that x value, plug it in to our original equation. She's plugging a 0 in, squaring it, multiplying it by -1, and adding 9. And so she got 0, 9 as her vertex. Okay, notice the vertex is in the center of the parabola. It's the turning point. So Ms. Delk put it in the middle. Then she's creating a function, so she's going 3 down, 3 up. And then remember what we just did on this test. We can plug in, we can realize the pattern, we can use a calculator, got multiple ways to go get those numbers that she's going. Okay, remember those little things create beautiful parabolas. Remember they're perfectly symmetrical. So remember -3 would produce 0, so would 3. -2 would produce 5, so would 2. -1 would produce 8, so would 1. And our center is at 0, 9. Okay, so that is a parent-sized parabola with a vertex at 0, 9, opening down. And our focus today is where it's going to cross the x-axis. Okay, notice that when a point is on the x-axis, his y value is now 0.
Hence, they're called zeros.
That's all right. Okay, so look at this beautiful parent-sized parabola. She crossed the x-axis twice, meaning it has 2 roots, otherwise known as x-intercepts, otherwise known as 2 solutions, otherwise known as 2 zeros. Our focus is on the x values of those roots. So notice she labeled those quickly, and then the answers we would put over here would be x equals, set notation, -3, 3, least to greatest, can't repeat. It's pretty easy. It's just expanding one thing of what we did last week. We graphed that last week. This week, all we're focusing on is where it's going to cross the x-axis. Okay, we're going to skip this one because it's pretty much like this one, standard form. We're going to let you try that one. Mr. Delk has the answer key so he can check it after y'all get done today. That way your notes are completed and it's perfectly correct. All right, so now we're going to focus on number 3. Notice Ms. Delk, it's in standard form. So of course she immediately went to axis of symmetry. She's plugging in for -b/2a and get x equals 1. Okay, so remember that's the vertical invisible line that divides the parabola into 2 equal parts. Then she plugs the 1 into her original equation. See in the red, she's done that math for you. She gets a -2 output, so her vertex is at 1, -2, and she puts it in the center because vertexes are always located in the middle of the parabola. She's doing a little bit of quick math because she knows the pattern. Okay, it's a parent-sized equation, so she knows it should fall 1, fall 4, fall 9. Okay, those perfect squares that we like.
Her hand's hurting.
She's writing quickly because it's Friday after school and we're ready to go home. All right, she's going to graph this beautiful little parabolas that we've created using the math that we know. So she's going to go put a vertex at 1, -2. She knows it's going to open down. That's a good thing. And then she's graphing those other points. Can't fit them all on the graph, so she's going to do what she can. She knows the basic pattern it's going in. All right, look what we have. Is that parabola ever going to turn upside down and accidentally touch the x-axis? No. Notice it's here, vertex, and it's a maximum points. This is a maximum he's ever going to touch, but he's going to go down forever, so he will have no roots. He will not have roots. So therefore, Ms. Delk over here put no solution, because meaning it doesn't have answers.
Remember, you got to remember that those are all synonyms for one another. So if we ask for solutions, we're asking for the x-intercepts, we're asking for the roots, we're asking for its zeros. I could ask any one of those ways, and you have to know their equivalent.
Okay. All right, leaving you number 2 to do, because it's not very hard. All right, now we're going on vertex form. So we wanted you to remember they can be in vertex form or in standard form. So on the back, we changed to 3 vertex form. Okay, remember these are the ones y'all like because the math is done for you. It says, here, take the vertex. I'm right here in the equation. You remember for vertex form, we're going to take opposite of h and keep the k.
Because we're going to be okay.
That's right. We like to be okay. Remember that's opposite of h, keep the k. Remember a is the same in both standard form and vertex form. Ms. Delk's watching her math. The vertex goes in the middle. She's going all the way up, all the way down. And remember the focus today is where does this parabola cross the the x-axis?
Yeah, definitely not the y.
Yeah, definitely not the y. Sorry.
This graph should be very narrow too.
It should. It's going up 3 times faster than a normal one. So remember, y'all have learned about this. This one will be super stretched or narrow or skinny, whatever word you're using.
I don't have your
She's
perfect
graphing
eyesight.
those little points. It's looking to be perfectly a little skinny. She's making it perfectly symmetrical. Looks like what she's doing to one side, she's doing the other. 19 is going to go off the graph, so we're just going to kind of leave that one there, but we know the pattern that would happen. Okay, look how many times she's going to cross the x-axis.
And this is where we run into issues when we're graphing to find roots. Technically, it crosses twice, but they're not at perfect lattice points, meaning they're either a fraction or they're an extremely long decimal. So because I can't accurately tell the person grading my paper, I can't tell the people on the EOC, this was not the best method to find this one's solutions. So tomorrow, we're going to teach you another way to find solutions that's more accurate, because you can't tell them fraction answers because you're guessing, and we don't guess in math. So I don't know what to put for number 4. I know it's got 2, I just don't know what they are. I could guess, but I don't want to guess. I want to know.
Yeah. Remember, we don't assume in math. We know we have ways to get those answers. Tomorrow and Wednesday, Miss Dilk will show you other ways to get those fractions answers.
Tuesday, Miss Fisher will show you.
Yes.
Miss Dilk will not be in here teaching you.
All right. So we're going to skip 1. So let you try 1, too. Mr. Dilk has the answer key, so you can quickly do it at the end. And we'll check and see if it's right. Okay, notice we like vertex form. That's the one we like because there's no math. Basically, the vertex is there. They're saying, here, take the answer. Ms. Delk quickly put that in vertex in the middle of her table. And she's doing the math real quick. This is going to be a beautiful parent-sized parabola, meaning the first point will rise 1, run right 1. But remember, that only works for the first point. All the little things we're trying to remind you about from last week. Okay, so she's graphing those points that she's created from vertex form. Looking beautiful and symmetrical. And this one, she can actually get all 6 points on the graph.
Ooh.
Or 7, I'm sorry, 7. Okay, remember the focus today is how many times does that parabola cross the x-axis? He crosses once. So that means we have one answer, one root, otherwise known as one x-intercept, otherwise known as 1, 0, otherwise known as one solution. So he would be x equals -4. Okay. All right, now this new big word you see down here, the discriminant. Okay. The discriminant is used to determine the number of solutions. It will not tell you what the solutions are. Let's get that straight. It will not tell you what the solutions are. It just tells you how many solutions. So if one of the test questions happened to be, how many times will this parabola cross the x-axis?
I don't want to do all
faster
this.
way. Right. Who wants to go up there and graph it all? We want to run this little discriminant formula. Bam, it tells us exactly how many solutions. Here's the problem is y'all got to remember the little rules. All right, the formula for discriminant is the discriminant is equal to b squared minus 4ac. You're going to notice that as another part of the formula here in a few days that we teach you. But the discriminant is d equals b squared minus 4ac.
And because the formula has A, B, and C, it must be in standard form for you to use this formula.
So notice we got 3 in standard form, 3 in vertex form. We'll talk about those vertex forms because Miss Dell, remember she just said, has to be in standard form because of A, B, C.
If you substitute from standard form into the discriminant and you get D is greater than 0, that means there are going to be 2 solutions. I don't know what they are, but I know it's going to cross the x-axis twice. If it's exactly 0, it's just going to have 1 because there's 1 0 number. If it's less than 0, it's going to have 0 solutions. Okay. So number 7 is in standard form. Quickly, I'm going to come over here and I'm going to tell myself who's A, B, and C. And I'm going to substitute into the formula.
Notice the directions to your left are saying use the discriminant to determine the number of solutions, not what they are, the number of them, 2, 1, or none. Okay, y'all are great at plugging in at this point. See how Ms. Delk plugged into b squared minus 4ac? She used her numbers in A, B, and C spot. She got the value of the discriminant right here. She did the math and she got the value of the discriminant is 9. 9 is greater than 0. Therefore, she has 2 solutions. If we graph that parabola, we know it's going to open up and it's going to cross the x-axis twice. Yep. We don't know where, but we know it would cross twice.
Okay, let me do another one for you. So I've got standard form A, B, C. A is 1, so it should open up, which means the vertex would be a minimum, and it also means it's going to be the size of a parent, just reviewing. But to do discriminant formula, it's D equals B squared minus 4AC. Notice that when I substitute, I do substitute into parentheses because it does affect as far as my signs go. So I'm going to have 9 minus 40, which is a negative 31. That is less than 0, so that means I'm going to have 0 solutions. This will never cross the x-axis. We haven't moved in quite a while, as you can tell, because we've been talking to y'all, and the lights just went out.
Okay, so notice this parabola. Think about it. If it's opening up and it has no solutions, it means it's actually opening above the x-axis somewhere in a quadrant, and it's going to go up forever, so it's never going to cross the x-axis. That's what it means to have no solutions. Never going to touch the x-axis.
Okay, we're going to let you try this one in standard form, and we're going to move on to vertex form.
And we're only going to do one because these are easier.
These
we
are
like
really
these.
easy. Okay, remember, to use a discriminant formula, you have to be in standard form. So you could convert this to standard form, but that's going to take you a long time, and I don't want to do that. What I'm going to do is I'm going to use my knowledge of vertex form to quickly kind of sketch a graph and then determine how many solutions. We like this form because it gives us the vertex. I know that A is positive, so my graph is going to open up. And to find the vertex, I'm going to be okay. So my vertex is going to be a negative 2, 4. So if I just quickly did that, negative 2 would be over here somewhere. Positive 4, it's going to go there. And A is positive, so the graph's going to open up. It's going to look something like that. Just by sketching it quickly, I now know that it's never going to come in contact with the x-axis. Therefore, I have 0 solutions.
See how much faster that was than using math, using a formula, accidentally making mistakes. There's so much room for error. This, y'all can quickly sketch. Bam, I can quickly sketch 2, 4, negative 2, 4. No, it goes up. It has no solutions.
Let me show you another one.
Faster.
Vertex form. A, H, K. Remember, if you don't see a K, it's because it's plus 0. Vertex form gives us the vertex because we're going to be okay. So 3, 0 would be right here on the x-axis. A is positive, so the graph's going to open up. And I can now see that it's going to cross the x-axis one time. So I'm going to have 1 solution.
See how much easier that is than transforming to standard form?
You could transform. I could. We know how to do that, but we're more likely to make a mistake. So in standard form, we're going to substitute, know our rules. In vertex form, I'm going to quickly sketch and see how many solutions it will have.
Okay, so we left you 2 here. 1 to practice vertex form for roots, 1 to practice standard form for roots. Here's the biggest thing we need to remember. There are 4 words that they're allowed to call roots.
And that we'll ask you on the test.
Yes, roots, x-intercepts, solutions, and zeros. All 4 of those are the same thing in math. So if you hear us say any of those 4 words, it's technically the same thing. Okay, remember our next step so that you are seeing what we're working towards. Our next goal is to be able to find roots when they're fractions like this one. Remember, we couldn't answer this. But on Tuesday and Wednesday, we will be able to answer that. Graphing is probably not the best way to go to, but it's the easiest to start with because you're already familiar with graphing.
And y'all are good at it.
And you're good at it. So we'll definitely give you those backup plans later on this week. Okay?
Okay.
Homework next, please.